Assalamualaikum. Hi guys, in this video we are going to try together two examples based on variation in atomic radii. I'm going to explain based on example 6 first. You have to compare the atomic radius between lithium and potassium. So this is one question. You have to compare between two different elements. So how you want to answer this question, I will introduce to you step by step how to answer this part. So we got 3 steps here. First thing first, no matter what, you have to write the electronic configuration for each element that you want to discuss. So in this case, I have lithium and I have potassium. After that, step 2, you need to determine which factor. So which factor that we need to determine, it depends whether it will be ZEF or shielding effect. It can be either one. So how? I'm going to determine based on my n value, principal quantum number. So you have to determine the highest n value for lithium, which will be n equals to 2. For potassium, which will be n equals to 4. You can see that here and here. So only for the highest n value. If you see here carefully, you got different value for n. So automatically the factor will be shielding effect. Hence, the layout that we are going to use is NSAS. So I'm going to explain based on the subject that I will use. For example, I will choose potassium as my subject because we are comparing potassium with lithium. So my first point will be talk about n value. So I will write it down. K has higher n value than lithium. After that, we talk about shielding effect. So which one has the higher shielding effect? Of course, we talk about K right now. So K has higher shielding effect than lithium. And next, when the shielding effect increase, the attraction becomes weaker. But please be specific what attraction it is. So nucleus attraction with the valence electron for K is weaker than lithium. Hence, we can conclude that K has bigger atomic size than lithium. So this is how you write the answer based on comparison between two different elements. If you take a look here, there is no arrangement at all. I just straight away put my answer, but make sure in each bullet points that you talk, you have to put then lithium, then lithium, then lithium, then lithium. It means that you are comparing between two elements. Dalam kes ini antara potassium dan juga lithium. So settle for example 6. Next, we go for the next example. I have to discuss the atomic radius between sodium, aluminium and argon in decreasing order. So the question is upgraded a bit, where still the same, follow the tips that I asked you, but in this part you have to determine the arrangement for step number 3. So arrangement only needed when you have 3 or more elements that you need to discuss. From the previous example, you got example 6, only 2 elements. That is why you don't have to put the arrangement. So I hope you are clear for this part. And after that, just follow the layout that you are needed. So let's answer this question. Step 1, you have to write the EC first based on each element. So I got for sodium, aluminium and argon. After that, I'm going to determine which factor. Remember, in order for us to determine which factor, we need to determine the highest n value first. So you got n equals to 3 for sodium, aluminium and argon. You got here, here and here. So all of these got the same value. Hence, we can know that the factor will be effective nuclear charge, ZEF. Automatically, I'm going to use acronym PISAS. So here, you all should know that sekiranya n value different, macam example 6, faktor dia adalah shielding effect, kita guna N sus. Kalau this example 7, N value is just the same, so faktor dia adalah effective nuclear charge, the layout will be based on acronym PISAS. Now, we are going to continue for the next part where I need to arrange them in decreasing order. So the question asks specifically for decreasing order. So this is how my tip for you. Sekiranya increasing order, we are going to start with small less than big. If it's decreasing order, we are going to start bigger more than small. So how you want to do the arrangement? Take a look at the layout first. When you have the highest proton number, so the size will be the smallest, or vice versa. So you got sodium is the lowest proton number, so the size for the sodium will be the biggest one. So I will have my arrangement sodium greater than aluminium greater than argon. So argon has the smaller size. So now I'm going to explain. We need to follow the layout based on step 4. But please make sure you need to write based on your arrangement, but in 2 paragraphs, because you are comparing between 2 elements one by one. So I'm going to start with Na with Al first. So this is going to be my first paragraph. So I will have Na has smaller proton number than Al, smaller ZeV than Al, weaker nucleus attraction with valence electron than Al. So Na has the bigger atomic size than Al. So this is for the first paragraph. However, you are still not complete yet because you have to explain for variation between Al and Ar. So I'm going to continue my second paragraph. So we can write the first point is Al has smaller proton number than Ar. So Al has smaller effective nuclear charge than argon. So aluminium has weaker nucleus attraction with valence electron than Ar. Hence, Al has bigger atomic size than Ar. So settle for the second paragraph, variation between Al and Ar. So if you take a look here, this is for Na greater than Al, and this is for Al greater than Ar. This is how you write your explanation in 2 different paragraphs based on your arrangement. So benda yang paling penting adalah your arrangement. If your arrangement is wrong, automatically your explanation will also wrong. So please make sure you follow my tips step by step. So that's it for this video. I hope you all can understand how to explain the variation in atomic radius for specific elements. That's it for this video. I will see you in the next one. Bye!